All right, Mariyam. So see, Mariyam, since it's a very short class today, let's just start with your first unit of physics class. That was electrostatics. So, which, by the way, lesson you're doing currently in your school?
We are doing the third chapter.
Current electricity. So that is complete. Are your vacations going on right now?
Yeah, I'm currently on summer vacation break.
So before the summer vacation, third chapter was over completely.
Yeah.
So, Mariam, right now, since it's a very short class, so you can study electric charges and fields introduction today. Otherwise, after this class, whatever batch suits you, whatever timing suits you, whichever chapters, because in some of the batches, current electricity is going, so you can join it from there. In some chapter number 4, magnetics is going, so that you can join. So that can be discussed later. Let's just start, since very short time is there, let's just start with this unit. So your first unit of electrostatics comprises of 2 lessons. Chapter 1 of NCERT Physics Part 1, that is electric field and charges. And chapter number 2 of NCERT, that is electric potential and capacitance. Now, electric charges and field, this has a very basic quantity which we call as the electric charge. So what is meant by electric charge is that it's the intrinsic property of matter which gives rise to electric forces. See, what's the meaning of this? Basically, electric charge is what? It's the fundamental property. With the help of electric charge, you can define other quantities like electric forces, you can define electric potential, you can define electric fields, you can define various other charges. And all those can keep on going. And when they are in motion, then you study current electricity. When they are at rest, you study electrostatics. So first in 2 lessons, you deal with charges at rest. In the third chapter, you have velocity, accelerations. All these terms are involved regarding a charge. So electric charge is basically what is the basic or intrinsic property of matter that gives rise to electric forces. And Mariam, one more thing, just don't write down anything, don't note it down. I'll give you time, sufficient time I'll give you, so you can copy each and every step properly. So I'll give you time, don't worry about it. Now, 2 things that you have to remember apart from the definition of electric charge. One is the SI unit. SI unit of electric charge, you must be already aware of it. Do you have an idea about the SI unit of electric charge, Mariam?
No.
See, electric charge SI unit is basically Coulomb. Coulomb's law you must have heard of in electrostatics, electric physics you must have heard of. That was the name of scientists. So Coulomb is basically the SI unit. That's why we keep on writing charges like 4 coulomb, 5 coulomb, etc. and so on. 5 microcoulomb can be added, 4 nanocoulomb can be written, and different methods are there. But basic SI unit is coulomb. This is denoted by capital C. And by the way, electric charge is denoted by capital Q. Now, CGS unit of this electric charges, you must not be aware of it. A CGS unit is rarely used, but you should be aware. Either it's stat coulomb, just add the word stat in front of this coulomb. So this becomes stat coulomb, or another SI unit is there. That is electrostatic unit. Electrostat unit. So electrostat unit is there. In case of electrostat unit, you write or represent it through ES. So these are the very basic things regarding electric charge. Now there are types of charges present. Different types of charges are there that exist in nature. But 2 broad categories which all of us know from the lower classes. Types of charges basically involve your positive charges as well as your negative charges. Now, I'm just asking you one question, Mariam. It's a general question. You can just answer it randomly. No need to worry about it. There are 2 groups of charges, positive and the negative. According to your knowledge or according to you, the naming of positive charge and the naming of this negative charge, does it have any basis for naming it? Or do you think it's randomly named as positive or negative? Or you think there's some basis for naming it as positive and naming it as negative?
Well, I believe there are some bases for naming it.
Basis. See, that's the answer of most of the students. But in reality, what happened, this scientist, the name of the scientist was Franklin. So he observed in nature, he was performing various experiments on electric charges. He was basically working with electric charges. Then gold foil experiment and different experiments also came. So he observed that basic nature of the two charges exist, which can be divided into two groups. If charges are taken among, both of the charges are taken from each group and are attracted, there it is seen that it is attracted. And if the two charges are taken from the same group, within the same group, intra group, they are taken, so that attraction doesn't actually lead to attraction, it is leading to repulsion. So he noticed what there are, in short, story short, there are two types of charges that exist in nature. But there wasn't basis of naming these charges, since more discovery was left, experiments were left to be done. So Franklin, no, randomly, arbitrarily, he named these two groups of charges. One as positive, other one as negative. And by convention, we have been using it as positive, negative, positive, negative. It's not like, had he named it another quantity, like instead of positive, he would have named it that north, or he would have named the negative charge as south. In today's time, we would have been using north and south instead of using it as positive and negative. So this has no basis, it's just random. The types of charges, there are two types of charges, positive charges and negative charges. Positive, negative attracts, positive repels, negative repels. Like charges will repel each other, unlike charges will attract. This is the basic theory of electric charge. Now we have to relate electric charge with electrons also, because electrons, protons, these will be continuously used in your physics. You must have read or heard of this chapter from your index of the book, semiconductors. That's the last lesson of your 12th standard. So in that lesson, semiconductors also. Till that lesson, this whole concept of electric charge is required. That's why we do it in the very beginning. Electric charge, once you have understood, throughout this is used. Because one more thing is there, that is known as the electronic charge. How much the charge is contained by a single electron. That we'll discuss later on. Just note down this page first. First you note it down, let me know when you're done, then we'll move forward. And if you're having any difficulty, if you're having any doubts, you're free to ask. Either you can write me in the chat box or ask me, or you can unmute yourself. Intrinsic. 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 Intrinsic basically means the fundamental, very basic property. All right, Mary. So now see, another basic thing in this topic is that, see, once you join the other batches, you will be given backup of these, but it might happen that you would be preferring some chapters so that you can discuss on later. Now see, basically, the charge, this electric charge that is contained in a single electron, this value you have to keep in mind and you have to remember. This value is 1.6 into 10 to the power minus 19 coulombs. Because in your examination, either you're appearing for your 12th board examination or even after your 12th class, you're appearing for your competitive exams, this value will not be given. And this value will be used throughout your physics, then in your modern physics and in your semiconductors, all the physics that you have in class 12. So basically the minimum charge that exists in nature, the single electron, the amount of charge which it is holding, this value is 1.6 into 10 to the power minus 19 coulombs. And we call this value as the electronic charge. See, for one electron, you can see plus minus sign basically shows the nature of the charge. Electrons are known to be negative charges. Proton are said to be positive charges. So for electron, I can write it as minus 1.6 into 10 to the power minus 19 coulomb. For a proton, I can write it as plus 1.6 into 10 to the power minus 19 coulomb. But the amount of charge held by the electron and the proton remains the same, which is 1.6 multiplied by 10 to the power minus 19 coulombs. Now, if the amount of electrons in a body balances the amount of protons in a body, then we say that the body is a neutral body. Means neither it is negatively charged nor it is positively charged. You say the body is a neutral body. And for a body to be a neutral body, the condition is that all the amount of negative charges should be equal to the amount of positive charges. This is the basic condition for it. And when this happens, we call the body as a neutral body. So note down this page as well. And any queries you have, just ask me. And do remember this value, because this value won't be given in the questions. All right, Mariam. Now, see, one last portion that I'll cover with you right now is that the structure of atom we have to look in a bit to understand the transfer of electron. This is an easy topic, but we have to discuss it. See, structure of atom, you already have this lesson in your chemistry when you were in class 11. So you already are aware of the structure of an atom, but let's just discuss it. See, the basic structure of an atom consists of what? It consists of a nucleus, which consists of all the positive entities like protons. And then we have the negatively charged electrons revolving around in orbits. Now see, the protons are held in the nucleus with the help of strong nuclear forces. While these electrons are also attracted. So these electrons are attracted with the help of electric forces. So two kinds of forces exist in an atom. First is the nuclear force, other one is the electric force. But there's one relation. Nuclear forces are far more times stronger than electric forces, approximately around 100 times stronger than these electric forces. This is the relation. So see what happens basically. The strong nuclear forces, these hold the protons so tightly, and it becomes difficult for the protons to move out, because the nuclear forces are very strong and they hold the protons tightly, whereas electric forces are weaker forces, so the electron and the nucleus bond can get broken up. So just tell me one thing, according to you, Mariyam, should the electron move out of this atom right now according to this data, or the proton should move out?
Electrons should move out.
Electron should move. That's the reason why we have transfer of electrons only and not the transfer of protons. The reason is just strong nuclear forces. Now the body that loses these electrons because of the weaker electric forces, that body, since it has lost the electron, it becomes positively charged body. And the bodies that gain these negatively charged electrons, it becomes the negatively charged body. And as already discussed, when the number of electrons is equal to number of protons, we get the neutral body. Is this portion clear?
Yeah.
All right. So note down this well. While writing, if you get stuck anywhere, ask.
Just one doubt. As you said, the nucleus contains of the protons. Can't the nucleus contain electrons?
No, the nucleus doesn't contain electron. This we'll see in Bohr's atom also. Just a second. See, in case of the charges, you must have heard of the Bohr's atomic theory.
Yes.
Yes, Maya. I was saying that when in your 11th standard, you must have heard of Bohr's atomic theory, Maxwell's theory, and all these theories. In case in 12th also, we'll discuss it. When we have a chapter named Atom. In your second term, you have it in your part 2. There you will see that protons cannot hold the electrons because it makes the atom unstable. So ultimately, it's only the positive charges that are held in the nucleus, and electrons are allowed to revolve around it. All right. If the electron goes into the nucleus, then whole your atom will become unstable. Clear?
Yes. Thank you so much.
Just note it down or let me know when you're done.